Hi everyone, I'm Zhen Hui, this year's Esri Young Scholar Award recipient, and I'm glad to see we have many friends from Singapore and around the world tuning in to see how we can forge a resilient future through integrated master planning and GIS. I will illustrate this using my project on the concept master plan of Paya Lebar, a new town. Singapore has been and continues to be carefully designed to exemplify a sustainable and resilient livable city. A livable city can be defined to embody three outcomes within the land use, which can be enjoyed by all. The first outcome is to support competitive economy building by attracting investments and providing jobs. The second outcome is to create a sustainable living environment by ensuring long-term availability of vital resources for our future. The third outcome is to provide a high quality of life with shared identity to forge greater social resilience. However, Singapore faces perennial challenges for land planning of a small city-state. We have limited land resources, just over 720 square kilometers. We have competing land needs, such as whether to have more residential housing, more commercial buildings, or preserve the natural greenery. We are also not immune to the twin effects of climate change and urban heat island effects, which will make staying outdoors in the future even more uncomfortable. How then can we optimize our limited land resources while addressing competing land needs for present and future generations, and make our city more livable all at the same time? And the unifying question is, how can GIS help to answer these questions and fit into the entirety of this inherently complex system of urban plans and layers? One of the solutions lies in master planning across the scale. In Singapore, macro-scale planning can be defined to be at the national level, where a whole-of-nation planning is conducted to meet present and future needs. At the other end of the spectrum lies the micro-scale, which can be defined as precinct-level planning. It is at this scale where urban planners, designers, and architects infuse the neighborhood's character and heritage to design community facilities for a livable and lovable living environment. In between these two ends lie the mesoscale, and in Singapore's context, this is planning at the town level. New towns are designed to meet competing national land needs, such as housing, environment, and commercial, as well as to forge a sense of identity amongst the residents living within the precinct. It is at this mesoscale where I have used GIS to develop a systems approach towards the formulation of a concept master plan of Paya Lebar, a new town. I call this town the plant for short. The land to be redeveloped into the plant is Singapore's Paya Lebar Air Base, which is also the former Paya Lebar Airport. This was Singapore's second international airport until the early 1980s and has since been an operational military airbase surrounded by industrial estates, as shown in purple. The most distinctive feature is the 3.8-kilometer runway that travels across the airbase. As for future plans, the airbase will be relocating from the 2030s onwards. The total land area, including the industrial estates, is approximately 18.5 square kilometers. And with GIS to assist with the master planning process, the area can transform into the highly livable and sustainable plants. But before going to the analysis, I'd like to share my three-step thought process in formulating the concept master plan. The first thought process is setting planning objectives, which can help pave the way for purposeful GIS analysis. For this concept master plan, I wanted to illustrate a vision of future communities in 20 to 30 years and explore exciting new ways to live, work, learn, play, and move within a livable new town. The concept master plan should reflect the rich aviation heritage through adaptive reuse, since existing infrastructure such as the runway and control tower building can be repurposed into other uses for future generations to utilize and appreciate. The second thought process is defining planning principles, which are meant to guide the thinking process towards accomplishing the planning objectives. As I envisioned the plan to be a microcosm of a livable city, the three outcomes of economy building, sustainable living environment, and high quality of life can be synthesized into two planning principles. Transit-oriented development aims to locate more mixed-use commercial, community, and residential spaces around rail stations to promote compact land use while providing maximum amenities at the doorstep. This planning principle is in line with a push for a car-light urban environment in Singapore, where public transport will be the transport mode of choice in the future. Instead of having more private vehicles, they can contribute to greater environmental pollution. Environmental planning ensures green spaces remain relevant and serves as places of relaxation and recreation, as well as transit and ecological corridors for all to enjoy. Having more greenery in our urban environment plays a role in providing outdoor thermal comfort from the tropical weather and breathe life into an otherwise lifeless concrete jungle. The third thought process is integrating planning findings to develop the concept master plan. The final integrated concept master plan will be guided by the 2 planning principles to meet the 3 planning objectives. With these thought processes, let's deep dive into the GIS analysis. For the analysis, I divided the workflow into 5 levels, which you can keep track on the upper right corner of the slides. The first level is to conduct spatial analysis of essential facilities, which aims to analyze the unique spatial distribution to provide an indicative quantity and location within the plants. Essential facilities share a common characteristic for proximity-based spatial distribution, and for this project, I have further subcategorized these facilities into 2. Emergency facilities like police and fire stations need to be located within optimal distance of each other for a shorter response time to save lives. Amenities such as green spaces and rail stations enhance our city's livability and mobility convenience and have been mandated by the Singapore government to be located within a 10-minute walk from nearby residential areas. Using police stations as an example, back-end data analysis was conducted to develop a unique 2-tiered buffer distance. By visualizing this on a map, we can deduce the quantity and location of future neighborhood police stations. A similar analysis was conducted for green spaces, such as parks and park connectors, to understand the current spatial distribution. With this analysis, I was able to deduce the planning parameters for the essential facilities in the plants to inform the design of the concept master plan. Level 2 of the analysis is to seek out potential rail corridors for plants by identifying optimal locations for rail stations as well as the shape of the rail lines to serve existing and future residential areas and workplaces. Here, we have a map of residential areas with low proximity to rail stations. The Singapore's Land Transport Authority targets to have at least 8 in 10 households located within a 10-minute walk from the nearest rail station by 2030, which translates to 400 meters in Singapore's context. To locate residential areas that are much further away from rail stations, I doubled the buffer to 800 meters for this map. Indicated in the map are the Seletar Airport and Seletar Aerospace Park, as well as the Paya Lebar Air Base and surrounding industrial estates, which will be relocating from the 2030s onwards. Visually, I identified a potential inter-town rail corridor that connects the residential areas circled in blue. The curvilinear inter-town rail line will serve both the residents and employees working in the existing Seletar Aerospace Park, which is home to over 60 multinational companies. Within the new town, the buffer between residential areas and rail stations will be kept at 400 meters, which is in line with the national planning targets. With the first rail line passing through the town, I decided to have another circuitous rail line that loops around the town. Both the inter- and intra-town rail line are envisioned to integrate with the national rail network by interchanging with existing and planned rail stations to enhance connectivity within the plants and with the rest of Singapore. This can help promote rail transport ridership and contribute to a car-light urban environment. Level 3 is a comprehensive population density analysis around community features, which aims to quantify population density and provide an indicative residential land area required within the plants. Community features are commonly located in town centers or neighborhood centers to serve the surrounding high-density residential population with the highest potential footfall. This means that the population density around these features can serve as a baseline proxy for the plants to ensure the town supports a sufficiently large residential population. There are two possible workflows to conduct this population density analysis. The first is a basic in situ analysis, where the subzone population density is directly spatial joined to the point feature. However, this method does not account for a change in population density across subzone boundaries, such as if the point feature lies exactly at the boundary between a high and a low population density subzone. The more advanced method involves splitting the buffer based on the subzone boundary, recalculating the population density based on the area of the smaller polygons, and dissolving the polygons to obtain a weighted population density around the point feature. By applying a 400-meter buffer radius around each point feature, the raw weighted population density values were derived for 974 unique point features. To increase the speed of the analysis, I used ArcGIS Model Builder and another software to iteratively complete the analysis, since the workflow was similar for all the community features. Each of the raw values are then fed into a weighted analysis model to derive a range of population density around each community feature. By consolidating all the results, I was able to derive a range of 15,000 to 19,000 persons per square kilometer around each community feature. This planning parameter will be used to estimate the population size of the plant based on the area set aside for residential housing in the concept master plan. Level 4 of the analysis is to map the existing and planned land use of the airbase and surrounding industrial estates, which will help inform the land use for future adaptive reuse. As there are no reference maps, there are a few workflows that can be considered to develop a base map from scratch. Remote sensing and deep learning or AI can be employed, either with supervised or unsupervised classification to aid the identification of correct land use. The alternative is to hand map, which can provide the highest degree of accuracy but will be time-consuming. In order to choose the best workflow, here is a close-up satellite and road map imagery within the Paya Lebar Air Base. You may notice some roads and infrastructures in red are missing from the road map imagery, which makes it inaccurate to be used as a base map. Therefore, hand mapping was chosen to map the present land use from satellite imagery and includes planned land use from the URA space. At this point, I would like to caveat by highlighting this method accounts only for surface land use and excludes considerations for topography as well as subsurface use and structures. I will share more about these considerations later in the presentation. The fifth and final step of the analysis is to integrate all the findings into the concept master plan. This requires amalgamating the findings to form a single integrated land use plan, which is aligned to the two planning principles and meets the three planning objectives. Here, I present the concept master plan that was designed from and informed by the 5-step analysis. Let me share some key highlights of the plans. Out of the residential areas that are represented in beige, 7 in 10 households are located within a 10-minute walk from the nearest rail station, enabling residents to travel anywhere within the plants and to other parts of Singapore quickly. As part of the transit-oriented development planning principle, mixed-use commercial and residential land use are located at each rail station to promote compact land use and provide maximum amenities for residents staying near the rail stations. Employees will be able to work smarter in the new commercial center that is located at the heart of the plants and is anchored by the 3 rail lines to shorten the commute. The first rail line is a cross-island line in green that runs across the plant from east to west of Singapore, which makes it ideal for workers staying further away to reach the new commercial center quickly. The second rail line is the proposed underground Seletar line in blue that starts from the north-south line at Yishun, interchanges with the cross-island and north-east lines at Hougang, and terminates at the Thomson East Coast line at Siglap. The third rail line is the proposed elevated Paya Lebar loop in pink, which loops around the plant in a circuitous fashion and interchanges with the cross-island and Seletar lines. Residents can look forward to playing and placemaking at the runway park, which has been repurposed from the original runway to be a green space contiguous with housing areas for recreation purposes. The runway park will also function as an active mobility superhighway for users to move across the town quickly without having to stop at traffic lights. This can help promote safety and encourage greater active mobility uptake within the plants to be a car-like urban environment. As part of environmental planning, the existing forested areas in the airbase can be repurposed as the forest park to function as an ecological corridor parallel to the runway park and for residents to explore. There's so much heritage within the airbase to appreciate, and hence, noteworthy infrastructure such as the control tower building can undergo adaptive reuse as community centers with a lookout point overseeing the runway park. To facilitate convenient movement within the plants, the Grid Light Park Connector network provides dedicated space for cyclists and joggers to travel on and get to their destinations quicker and safer. Besides the park connectors, the integrated multi-story depot in the north will serve the 2 new lines, as well as a bus depot to optimize land use. And there you have it, an integrated concept master plan that is aligned to the 2 planning principles and meets the 3 planning objectives that we initially set out with. So, what's next for the concept master plan? Believe it or not, there are so much more work to be done to complete the plan, and here are 4 other considerations to think about. Ground conditions such as topography, subsurface use and structures, as well as infrastructure conditions must be factored in during the planning stage before any developmental works can begin. Regulatory framework such as population estimates, development control, and urban design should also be considered. Modeling is required in the areas of transportation demand, environment and ecology, and microclimate to ensure the built infrastructure can enhance the livability of the plants. There are also other important land uses that have long-term implications but have yet to be included into the plan, such as reserve sites, drainage networks, and underground space optimization. Some of these considerations can be resolved with specialized solutions such as ArcGIS Urban, City Engine, and GeoPlanner to assist with the 3D visualization and scenario analysis. So, before I wrap up the session, I would like to pose a question to the audience. If you were the master planner, how would you use GIS to develop your concept master plan? And what would be your considerations? I invite you to share your responses and queries regarding the concept master plan during the Q&A session. If you'd like to find out more about the project, you can click on the link or scan the QR code, and feel free to connect with me on LinkedIn. Thank you for tuning in and enjoy the rest of the conference.